Hi everyone, this video lesson will cover the event problems for the review, okay, on exam unit, on the unit 15 exam. So what I am going to do on number 2 is, since we have radicals on both sides of the equation, I'm going to take the square of both sides of the equal sign so we can cancel the square root, okay. So then this becomes 4x, because 2 squared is 4 and the square root of the square root of x is just x. And this gives you x plus 6. I'm going to subtract x. So then 3x equals 6 divided by 3. So then solution is x equals 2. Okay, and that's all for this problem. Number 4, true or false, is, okay, if f of x is equal to 2 times the square root of x minus 4 plus 1, and g of x is the inverse of f of x. Okay, so what this is saying is that in the function g, we have the point 9 comma 20. If this is the case, then in the function f, we should have the point 20 comma 9. Okay? Okay, so I pause the video briefly just to check. Okay, so instead of x, I'm going to plug in a 20. So then that's 20 minus 4, which is 16. And then the square root of 16 is 4, and 2 times 4 is 8, plus 1, that gives us a 9. So we do get this point. So the answer is true. Okay. All right, number 6. If 27 to the power of x equal to 9, what is the value of x? Okay, so in this case, what we do is we're going to take the inverse of the exponential. This is the base of the exponential, it becomes the base of the log. So then this is log base 27 of the number 9 is equal to x. Okay, so this is what we have been doing in class lately. So then I'm going to go to the calculator, press math, alpha math. This is a log with the base of 27, and the number we're taking the log of is the number 9. So this is 0.6666. So I'm going to round this to approximately 0.67. Okay. All right. Next one. Number 8, so this is asking us to expand. So this, we have the power rule here, and we also have the quotient and a power in the denominator. Okay, so I'm going to expand this. So this will be log base 7. Okay, and I'm going to bring that 3 to the front. That's the a. Okay, and since these two are in the denominator, so then this will be minus log base 7 of c. And then minus this c, b, I'm sorry, log base 7 of b. And then this c has a power, so that comes to the front, log base 7 of c. And that is the answer to number 8. Let's move on to number 10. So for number 10, we need to write this as a single log. This is minus in between. There's a power here. Okay, so that power applies to the 4. And then this power applies to the x. So then let me just write this in 2 steps. So then we have natural log of 4 squared minus natural log of x minus natural log of y. Now we know that 4 squared is 16, so I'm going to condense to a single log or natural log. So then the 16 goes in the numerator, and then the x to the third, which I forgot to apply here, goes to the denominator along with the y. Okay, so this is the answer to number 10. Number 12. For number 12, we need to expand. So notice this applies to this power, to the 4th. So I'm going to do this in 2 steps. So when you multiply the 4th times 3/4, this 4 and that 4 reduce. So then this just gives you x to the 3rd, right? And this is plus, so that means we can apply the product property. So then this becomes log base 3, the 6 will be first, and then this is x to the 3rd, and this is condensed as a single log. Okay, so that is number 12. Let's go on to the next page. On this page, let's go over number 14. Okay, so number 14, this is asking us to solve and round the answer to earnest hundreds, and then we need to show work, just like we have been doing in class. So I'm going to divide by this 3 first, so I can get this by itself on one side of the equal sign. So then I have x minus 2 to the 3/4 power is equal to 8. Then what I am going to do here is I'm going to take the reciprocal power, okay? So then this is 4 over 3, and this is also 4 over 3. So then this gives me x minus 2 is equal to, then I am not going to do this by hand, I'm going to use a calculator. So 8 to the power of 4 divided by 3, and it gives me 16. So then this equals 16, then I'm going to add 2. So the solution is x equals 18. Okay. All right, let's go to number 16. Number 16, first I'm going to jump or add that 2 to the other side. So then we have 2 times the common log of 3x plus 1 is equal to 2. Then I'm going to divide by 2 to get the log isolated. So then this is common log of 3x plus 1 is equal to 1. Then I'm going to take the inverse of the log. The base of this log is 10, so it's going to be 10 to the first power equals 3x plus 1. But 10 to the first is just 10, right? So 10 equals 3x plus 1. Then I'm going to subtract 1. So then this gives me 9 equals 3x, then divide by 3. So solution for this one is x equals 3. Okay, number 18. We got to have all the logs on one side of the equal side. So I'm going to move this log to the other side. Okay, so then we have log base 3 of x minus this 6 applies the power to the 2. Okay, so this is minus log base 3 of 2 to the 6th power. And then 2 to the 6th is the same as 64. So then this is log base 3 of x, and I forgot to do the equal 0 here. Okay, minus log base 3 of 64. Then condense to a single log. Log base 3 of x over 64, applying the quotient property, is equal to 0. Then I'm going to take the inverse function. So 3 to the 0 power is equal to x over 64. But we know that any number to 0 power is 1, so then I'm going to come here for the sake of space, say 1 equals x over 64, write a 1. When we cross multiply, 1 times x gives us the x, and 1 times 64, so that means x equals 64. And that's a solution to number 18. Okay, number 20. This one here, I'm going to use, let's see, for this one, I'm just going to use a calculator, okay? So I'm not going to do that one by hand. So I'm going to press the math, alpha math. The base of this log is 6, and the number we're taking the log of is 0.07. Then press enter, and it gives me negative 1.4, and it continues. But don't forget, logs don't have negative numbers in their domain. Therefore, this one has no solution. Okay, don't forget that if you end up with a negative answer for a log, there is no solution, because negative numbers or 0 are not in the domain of the log because of the 0 because of the asymptote, and negative numbers because it's not in the domain of the function. All right, number 22. This is an exponential function, so I'm going to take the log. This is the base of the exponential, then that becomes the base of the log. So log base 2 of 16, okay, is equal to the exponent, which is 3x minus 5. Then I'm going to add 5. So then this becomes log base 2 of the number 16 plus 5 is equal to 3x. Then I'm going to divide by 3. And then I'm going to enter all of this at once in the calculator. And that'll give me the approximate value for x. Okay, so let's see. So this is, I'm going to get the fraction on the calculator. So then I have math, alpha, math. The base of this log is 2. The number we're taking the log of is 16. Scroll out, add 5, then scroll down, enter at 3, press enter, and it gives me 3. So this is exactly 3. Okay, so this is equal to 3, and that's a solution to number 22. Okay, number 24, the last one that I'm going to do in this video. I'm going to add the 5. So then we have 4 times e to the x minus 1 is equal to 64. Then I'm going to divide by 4. So then we have 8 to the x minus 1 equals 64 divided by 4 is 16. Then I'm going to take the inverse of the exponential, which is going to be the basis, the number e, the natural number e, so it's going to be the natural log. So natural log of number 16 is equal to x minus 1. Then I'm going to add 1. So then I'm going to do this in the calculator. Natural log of 16, and then add 1 more to it. So plus 1, and it gives us 3.7725, so approximately 3.77. And that's a solution to this equation. Thank you for watching. I'll see you in the classroom. Bye-bye.